1, 3, and 5. Oops. 3 is here, and 5. So those are the zeros. Now it says it has to have an even function, and there is no other information. All I know is that both should either be facing up or both ends should be facing down, and I'm just going to choose which one because there is no other information telling me, right? So I'm going to be an optimist today and point up. So just go this way, right? I have to have a turning point there to hit the other 0, then a turning point somewhere to hit the other 0, then another turning point to hit the other 0. Do I know how high the maximum is going to be or how low the minima are? No, I don't have enough information yet. Okay? All right, and that's good enough. Okay? You can make them symmetric.
That's it?
That's it. Okay. Here we go. A 5-degree function with zeros at these points, right? So look, there is a degree of 5, but only 3 real zeros at -4, at 1, at -1, and at 3. But what does the 5 degree tell us? What were you saying, Yali? That it's odd. So one end is going to be pointing, right? One end is up and one end is up. But look, we've got another piece of information that at x equals -2, there is a maximum. So at x equals -2, there is a maximum right there. Okay? So if there is a maximum there, then that is going to connect right there. And that means it's got to go down over there. I can't lift it back up because then it's going to cross the x-axis again, which it's not allowed to do that, right? So here, cross, go back, and we'll just go back up. Okay? Oh, is this right?
No.
Why not?
The minimum would be the -2.
Huh?
The -2 would be the minimum, not the maximum.
No, that's right.
Oh, wait.
But why is it wrong?
It's a maximum of negative, so you're not positive. 5 degrees. It's 5 degrees. It should be 5 0.
Nope.
The maximum is -2, not positive.
No, it's a -2.
Where do you see a -2?
X equals -2.
But where's the -2?
At x equals -2, at x equals -2, there is a maximum.
Oh, I thought I need to go
Right.
the other way.
Okay, sorry, I know,
Because it only crosses.
if this is a 5, if this is a degree of 5, it's going to have 4 turning points.
Wait, how do you know that?
Well,
Because you subtract 1.
right. So 1, and then you can do this and make it have 5.
You got 4.
4.
Wait, why does it have 4 and not 5?
So the turning points is n minus 1. N degrees, degree of n means n zeros, n minus 1 turning points. Okay. Now,
I don't get it.
Wait, isn't that still 3? Because it doesn't go back over the actual.
Yeah, you didn't.
Because
The zeros are not, 0 isn't turning points.
yeah, 0 doesn't necessarily mean it's turning point.
the 0 is never a the 0 has nothing to do with the turning point. So a turning point is here, 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 here. Now, if you did this with the one we had before, it would still be okay because you don't have specific information to say that you're going to have extra turning points. But this is also another version for it. Okay? Yep.
For these kind of problems, can we add the turning points like anywhere?
Yeah. But you have to have that one at x equals -2. Yep.
Wait, so
Well, I mean anywhere as long as it makes sense for it, right? Yeah.
Oh,
don't you have to show the 4 turning points, otherwise it's not a 5-degree function?
No, so it could have up to 4 turning points.
Oh, this doesn't have to.
Correct, because it can also have up to 5 zeros. It only has 3.
So that
oh wait, so does it have to have 4 turns?
Correct.
So
we just did
didn't have to add it.
Right, that would have been right as well.
Didn't have to add that.
Correct.
So the one you did before would have been right.
Correct.
Wait, the one that you did before.
Would have been right as well.
Why?
Yeah.
Because it has
Because it has to
to
have up to 4 turning points. Yep. Okay.
I'm so confused why it has to have up to 4 turning points, not up to 5.
Okay, because that's just the formula for it. So the graph of degree n has at most n minus 1 turning points.
But what's n?
The degree. N is the degree.
591.
Okay, let's do this next one as well, and then maybe we can come back. All right, annual sales of televisions can be modeled by this function, where X is the number of years after 1995, and F of X is the annual sales in millions. So graph the function for 0 to 10. Go ahead and put this on your calculators, because we're sure as heck not going to do it by hand. And you're given a domain for it, 0 to 10. Okay? Now, when you graph it, you're obviously not going to see anything. Correct? Because this is like, you know, how many TVs are sold in millions. And again, it's way more than this. So, you see where, okay, so take a look for a minute. Look at this function, everyone. When X is 0, what would the y-intercept be?
599.
599. So you know your graph is going to go all the way up to at least that, right? So why don't we make it a little bit higher? So let's go to Window, Menu, Window Zoom, Window Settings. The X, min, and max are going to go from 0 to 10, okay? Because that's what I'm told in the problem. So I just hit tab until I go here. And then I'm going to go from 0 to, okay, so that's going to 600. Why don't we go a little bit more? Let's go to 800. Let's see what we see here. Oh, okay, that's not bad. I could even have gone a little bit more.
How do you know that it's 0 for the Y max?
Y min, you mean?
I meant Y max.
Okay, so look at what this is telling you. X is the number of years after 1995. F of X is the annual sales in millions. F of X, the Y values, are the sales. Well, you're not going to have less than 0 sales, right? That's the minimum. Okay?
Well, mine doesn't show.
Huh?
I did the same as yours, and mine shows like this.
Okay, so let's see what we did here. So let's just write down here. Right? So for Y min, we did 0. For Y max, you could do like 800 or more, right? 800 or plus, that works too, okay? Right, so determine the, determine the turning points of the graph in this domain and its end behavior. So how many turning points here? 3, right? And since it's x to the 4, it's got to have 3 turning points. Okay, now, end behavior is as x approaches negative infinity and as x approaches positive infinity. So for that, we can't go to the window because the window only goes from 0 to 10. We want x to go to infinity and negative infinity. So where are we going to look?
At the X to the 4.
At the leading term. It's even and positive, so both ends will face where? Up. So f of x will go to positive infinity for both of them.
But if one would be negative, so then the positive X would be...
Well, it depends on if there was a negative or positive coefficient.
But the
With
4 doesn't
X.
matter, right? Like...
Hang on, let me do this and then I'll take the what ifs, right? So analyze the graph for values x is greater than or equal to 10. Is it reasonable that the trend will continue indefinitely? So here we're saying that in the function says as x approaches infinity, f of x will approach infinity. F of x is the number of TVs sold in millions. So is it reasonable that that's going to be true? Are you going to be able to sell an infinite number of TVs? No.
Because you can't make an infinite number.
Right. So even though the function will increase infinitely, right? The function itself mathematically can increase infinitely, but when you apply it to the real life problem, you can't sell an infinite number of TVs, right? So you can say no, right? TV sales will not increase infinitely. Okay? All right. So, okay. So with that, turn this class at 2:20. All right, let me put up the book so you can start on the homework.
Page 3.